All right, the final grade 9 math exam. It's right around the corner, isn't it? If you're feeling that pressure, you are definitely in the right place. Today, we're not just going to revise, we're going to build a strategic game plan to help you absolutely nail it. So let's dive in. So, are you looking at your notes and just seeing this huge mountain of topics, from transformations to probability, and just feeling completely overwhelmed? Trust me, you are not alone. It's a whole lot to get through.
But hey, don't worry. We are going to cut right through all that noise. Together, we're going to build a super clear roadmap, zeroing in on the key concepts and exam strategies that you absolutely have to know to do well.
Okay, first up, let's dive into the dynamic world of shapes. We're talking about transformations, which honestly is just a fancy way of saying how shapes move, flip, and grow on a grid.
Okay, so the first thing you absolutely need to get is the difference between rigid and non-rigid transformations. Just think of rigid ones like moving a coffee mug. Its size and shape never ever change. But with non-rigid transformations, the size changes. The shape gets bigger or it gets smaller.
So, when we talk about those rigid movements, there are really only three main types you need to know. A translation is just a slide from one spot to another. A reflection is a flip over a line, kind of like looking in a mirror. And a rotation is a turn around a fixed point. Slide, flip, turn. That's pretty much it.
Okay, now what about the non-rigid ones? Well, this is all about changing size, and it's controlled by two things, a center point and this thing called a scale factor, which we just call K. And this K value, it's kind of like the magic number that tells the shape exactly how much bigger or smaller to get.
Okay, but here's where things get really interesting. What on earth happens if K is negative? A positive K just makes the shape bigger or smaller, but a negative scale factor? Oh, that's a 2-for-1 deal. It doesn't just enlarge the shape, it also reflects it through the origin. This is a classic exam trick, so definitely watch out for it.
So let's actually walk through this with an example so you can see it in action. You take every single coordinate of that original triangle, the x and the y, and you just multiply them by -2. So 1, 2 becomes -2, -4. 3, 1 becomes -6, -2, and you just keep going. It's just simple multiplication, but the key is you have to do it for every single point.
All right, we're done with the flat grid for now. Let's blast off into the third dimension. We are now talking about geometry, the study of 3D objects and, what makes them tick.
For your exam, you've got to know the anatomy of these shapes, inside and out. A face is just a flat surface. An edge is where two of those faces meet, and a vertex, well, that's a corner. So for a cube, that's 6 faces, 12 edges, and 8 vertices. Knowing these numbers for the common shapes is going to be super helpful.
So you might be wondering, okay, so what is the real difference between something like a cube and a sphere, or a pyramid and a cylinder? It really all comes down to their surfaces. Polyhedra, like cubes and pyramids, they're made up of flat faces. But things like spheres have curved surfaces, which means they don't have faces or edges in the exact same way.
Next up on our list, we're putting on our detective hats. Because data handling isn't really just about numbers. It's about collecting clues and finding the story that's hidden inside them.
You see, every data journey, and I mean everyone, follows these 4 logical steps. First, you collect the info. Then you organize it so it actually makes sense. Next, you represent it, with a graph or something. And finally, you interpret it to figure out what it all means. Collect, organize, represent, interpret. That's the path every time.
So, let's start here. Imagine we've just collected this data. Look at it. It's just a jumble of numbers, right? It doesn't really tell us much of anything just yet. Okay, before you do anything else, and listen, I cannot stress this enough, you have to put the data in order from the smallest number to the largest. If you skip this step, I promise you, your calculation for the median will be wrong every single time. It's the golden rule of data handling.
Once you've got your data lined up in order, the rest is actually pretty straightforward. The mean, that's just your classic average. The median is the one smack in the middle. And since we have 2 middle numbers here, 5 and 7, we just find their average, which is 6. The mode is the easiest one. It's just the number that shows up the most. In this case, 7. And the range, that just tells you the spread, just the highest number minus the lowest.
Now, let's talk about representing data. And this is another classic exam trap you need to watch out for. Bar graphs have gaps between the bars. Why? Because they're comparing separate categories, like favorite pizza toppings. Histograms, on the other hand, have no gaps. The bars are all touching.
That's because they show continuous data, like height or weight, where one group flows right into the next.
And that brings us to our final big topic, probability, which is really just the mathematics of chance. It's how we measure how likely it is that something's going to happen, whether that's flipping a coin or winning the lottery.
The key thing to get here is the difference between independent and dependent events. The best way to think about it is with marbles in a bag. If you pull a marble out and then you put it back, the odds for the next person are exactly the same, right? That's independent. But if you pull a marble out and you don't put it back, now the odds have changed for the next pull. That's a dependent event. What happens first totally affects what happens next.
Okay, deep breath. We've covered the core concepts. Now let's switch gears and talk pure exam strategy. This is your final game plan for the big day.
All right, here we go. This is your rapid-fire checklist for exam day. For transformations, know those coordinate rules like the back of your hand. For geometry, practice counting faces, edges, and vertices until it's second nature. For data, always stop and ask, should this be a bar graph or a histogram? And for probability, always state if events are independent or dependent. If you can nail these points, you're going to avoid a ton of easy mistakes.
And finally, maybe the single most important piece of advice I can give you. Show you're working. Seriously, even if you mess up and get the final answer wrong, markers can give you points just for using the right method. Those method marks can literally be the difference between passing and failing. Don't just throw them away.
So, as you walk into that final exam, I want you to remember this. This isn't just about passing one test. What you're doing is building a foundation, a way of thinking logically that's going to help you no matter what you do next. So take a deep breath. You've done the work. You've totally got this.